Here we have two capacitors. We have C1 is smaller than C2, Q1 is smaller than Q2. They are separately charged. So as you can see in the first case, they're separately charged, and then they are connected to each other so that the positive side will connect to the negative side. So as you can see here, positive side is connected to the negative side, and negative side is connected to the positive side of these two capacitors, okay, to determine the final voltage across the two plates. Now when we connect it, we have to look that in the circuit they are connected in parallel. When capacitors are connected in parallel, capacitor resistor doesn't matter, then voltage across each of them will be the same or the constant, okay. So if they're constant, then we can say that okay, if they're constant, and also when they connected, this negative charge with a positive charge, let's take just the half of it, okay, this side, okay. If you take this half of it, then what will be the Q total? Q total will be minus Q1 plus Q2, okay, because they will start rearranging and and they have to be added up. Now if that's the case, if the V is a constant, then we know that you have to find C equivalent capacitor. When the capacitor connected in parallel, it will be C1 plus C2, okay. This is a C in parallel, okay. If the V is constant across each capacitors when they are connected in parallel, then we can say that V is equal Q total divided by the C equivalent, okay. That means Q total in our case is minus Q1 plus Q2 divided by the C1 plus C2. So that's it, I think. So again, in the final equivalent capacitors, what will happen is that, so Q1 is smaller than Q2, right? So therefore you assume that this will be a positive Q, this will be negative Q, and then this is your C equivalent or C parallel combination, okay.